Namaste. Welcome to another session on algebraic expressions. In the previous class, we discussed how to divide a polynomial by another polynomial using long division method. In this session, let's learn how to verify the result of long division by division lemma, that is the Euclid's division lemma, or it's also called as division algorithm. So let's start with a simple example. So let's recollect, we're doing arithmetic. Let's say that I have a division fact, say let's say 12 divided by 4, right? So if we do the long division, 4 times 3, 4 times 3 will give me 12. So let's familiarize again. So this 4 is called the divisor, 12 is the dividend, right? And then this 3 is called the quotient, and 0 is our remainder. So recollect how we did this. So we said 4 times 3. So we multiplied this, and then we subtracted whatever the product we got, okay, from the dividend, and then we got a remainder. So this is a whole number because 4 times 3 is 12. So in this case, I have a 0 because 4 divides 12 equally or completely, and there are basically 3 4s in 12. Now let's say I have 17 divided by 5. My 17 is my dividend, and 5 is my divisor. So 17 divided by 5, when I divide it, I always take a smaller number. So I take 5 times 3, 15. And when I subtract it, I get 2. So this is my remainder. And this is my quotient. So in my division algorithm, I can write, right? In my division algorithm, I can write dividend is equal to quotient times divisor plus remainder. Yeah. So this is basically also what we call as the division lemma or division algorithm. So this is how we can cross-check. So let's do this cross-checking for 17. So my dividend is 17, quotient is 3, and my divisor is 5, my remainder is 2. So since I have an equals to sign, this is an equation, and this becomes my this becomes my LHS, that is the left hand side, and this becomes my RHS, that is my right hand side, and an equation is supposed to be equal, so both the sides are supposed to be balanced. Now is that balanced? So I have my LHS as 17, so 3 times 5 is 15, plus 2 will give me 17. So 17 is equal to 17. So this equation is balanced, right? So similarly, how do we, use this method to verify, division of polynomials by another polynomial, right? So that is what this session is all about. So let's start today's session. I have to try doing it through long division. I give you some time to try. I have x squared plus 17x minus 9, and it is divided by x plus 3. Can you try it? Okay. So the first term over here is x squared, and the first term here is x. So x times x divided by x will give me x. So this is going to be the first term of my quotient. So now I'm going to multiply x plus 3 by x. So that is going to be basically the product of it, which I'm going to subtract. So x times x is x squared plus x times 3 is 3x, right? So this is what I get, x squared plus 3x. Now I'm going to subtract this, right? And because I'm doing subtraction, I'm going to change the sign. So the sign of x squared is positive. So now this is going to become negative. The sign of 3x is positive. So this is going to become negative 3x. So now x squared gets cancelled. And I have 17x minus 3x will give me 14x. Now I bring down negative 9. Now the first term is 14x. 14 times x divided by x. So the x and x cancels. So it gives me 14. It's a positive 14. So I put plus 14. Now I'm going to multiply 14, right? I'm going to multiply x plus 3, which is my divisor, by 14. So now 14 times x is 14x plus 14 times 3, 42, right? It is 42. So I have 14x plus, that is not plus, it is minus. Yeah, plus 14, 42, right? I'm sorry, it is plus only, yes, because I have a plus sign here and then I have a plus sign. So this is a plus. So it has to be a plus. Okay, so I changed the sign, right? And 14x minus 14x cancels, and I have a negative, correct? I have a negative 42 and negative 9, so that gives me negative 51. This is my remainder. Now, so this is what we did yesterday. But then, it says verify. So let's say that let's say divide and verify. So basically verify your answer, correct? So now we have divided it. So we have got a quotient x plus 14, and then we have a remainder that is negative 51. Now, is this the correct answer? Because this is the first part of it, and this is the second part of it. So the first part is done. So now let's verify. Let's verify. So this is the second part. Verification. Okay. So verification, the same thing. Dividend is equal to quotient times divisor plus remainder, right? So I know the dividend. My dividend is x squared plus 17x minus 9. This is my dividend, which is on the left hand side of the equation. This is the equation here, the equals to sign. So this is the RHS. This is LHS. This is RHS. If our answer is correct, or if the quotient and the remainder is correct, then we should get LHS should be equal to RHS. So now what is my quotient? My quotient is x plus 14. X plus 14, and my divisor is x plus 3, and my remainder is negative 51, right? So now let's take this up. So x times x plus 3 plus 14 times x plus 3, correct? So now x times x is x squared plus 3x plus 14x plus 42, right? So this is what I've got, x squared, and I have like terms over here. These are the two like terms that I have. So let me add that up. So x squared plus 3x plus 14x, I can add it because I can add them because I have the literal coefficient and the power is same. So I just add up the numeric coefficient. 3 plus 14 is 17, x plus 42. So now this is the product of this, x squared plus 17x plus 42 minus 51, right? So I'm going to erase this. So I can 42 minus 51 is negative 9, correct? It's equal to x squared plus 17x minus 9. So this is the same So my LHS is equal to RHS, thus verified. Yeah, got it? Okay, let's go to the next one. I have 3p squared plus 6p plus 18 and should be divided by p minus 6. Yeah, can you try it? Okay, the first term of my dividend is 3p squared, and then the first term of my divisor is p. So 3p squared is nothing but 3 times p divided by p. So this p and this p cancels out, so I'm left with 3p. So this is my quotient. So when I multiply 3p by p minus 6 or p minus 6 by 3, I get 3p times p is 3p squared, and then negative 12, no, 18p, right? Negative 18p. So now I'm going to subtract this 3p squared negative 18p. This is subtraction. And I'm going to change the sign. The positive 3p becomes a negative 3p, and positive 18p becomes it's a negative 18p becomes a positive 18p. So the 3p and positive 3p and negative 3p squared get cancelled. I have a 6p plus 18p, so that will give me positive 24p plus 18. So I have 24p by p. So it gives me 24. So I have plus 24. Now when I multiply it, I get 24p then I have a negative sign. So 24 times 6, 144, right? So I have 144. So now when I subtract it, I put a subtraction sign. So this becomes negative and this becomes positive. So the negative 24p and the positive 24p cancels. And I have two positive numbers now here. So 144 plus 18. Correct? 162. I have 162 is my remainder. So now using the division, Euclid's division lemma, that is dividend is equal to quotient, or you can take it times divisor plus remainder, right? So my dividend is 3p squared plus 6p plus 18, correct? And then my quotient is 3p plus 24, 3p plus 24, and my divisor is p minus 6, and my remainder is 162. Okay, so now 3p plus 24 times p minus 6. So 3p times p, right? So 3p times p, and then we have that same one, right? Yeah. So I have 3p times p minus 6 plus 24 times p minus 6. So it's basically we are multiplying two binomials here. So it is 3p times p is 3p squared. And then I have 18p. Then I have plus 24p. Then I have a negative 144 here. 24 times 6. I think I did the calculation here. 24 times 6 is 144. Now I take this up and then I have plus 162. So I have 3p squared and then plus 6p. Then I have 162 minus 144, right? So this is 8, this is 5 over here, 1. So plus 18, which is equal to my LHS, that is 3p squared plus 6p plus 18. Therefore, my LHS is equal to RHS. Thus, we have verified that LHS is equal to RHS. Yeah. Okay. Are you getting me? Any questions for me? Please type in the chat if you have any questions, if you got it. So can I go to the next one? Aditya, are you around? Yeah. Okay. Next one. I have a squared plus 2ab plus b squared. That has to be divided by a plus b. Can you please try that? Let's say divide and verify. And verify your answer. So I have a squared is the first term of my dividend, and I have a, right? So it is equal to a times a by a. So it gives me a, as a and a cancels. So the first term of my quotient is a. So now a times a plus b will give me a squared plus ab. So I'm going to subtract that. So a squared plus ab. So I'm going to change the sign. So it's a positive a squared. So I'm going to make it negative. And I have a positive ab. I'm going to subtract that. Now I'll get negative ab. Now a squared, negative a squared get cancelled. And there is always a 1 over here. It's a ab, but there is a numeric coefficient as always 1. Right? So 2 minus 1 is 1, but we don't use it as 1ab, so it is understood that it is ab. And then I bring down b squared. So now a times b by a. So this a cancels, and then I've got b, which is positive b. Right? So now I'm going to multiply a plus b by b. So it is ab plus b squared. Correct? So it is ab plus b squared. And I'm going to change the sign. So ab becomes negative, b squared becomes negative. So these two both cancel. So ab is my quotient. Now, verification method or verification step. So my dividend is very easy, very popular algebraic identity, that is a squared plus 2ab plus b squared. And I have a quotient is a plus b times divisor plus remainder. So I have a plus b times a plus b plus 0. So you know this a plus b times a plus b should give me, okay, a times a plus b plus b times a plus b. Now a times a is a squared plus a times ab is ab plus b times a is ba or ab plus b times b is b squared. So I have these two like terms. Now I have a squared plus 2ab plus b squared, right? So my LHS is equal to RHS, correct? Yeah, got it? Okay, let's do a quick one. Another one. I have x squared plus 15x plus 56 divided by x plus 8. Can you try it? Okay, so I have x times x, that is x squared divided by x. So that gives me x. So I'm going to multiply this. So x times x plus 8 will give me x times x is x squared plus 8x. I'm going to subtract that, x squared plus 8x. I'm going to change the sign. So this gives me, this cancels out. And I have 15x minus 8x will give me 7x plus 56, right? Then I have next one is 7x, that is 7 times x by x, that gives me plus 7. Yeah. So now 7 times x plus 8. So I have 7x plus 56. So very simple. So plus 56. So I'm going to change the sign. So plus, that is positive 7x becomes negative 7x. Positive 56 becomes negative 56. So they both cancel out. So now using the dividend is equal to divisor times quotient plus remainder. So my dividend is x squared plus 15x plus 56. My divisor is x plus 8. My quotient is x plus 7. And my remainder is 0. So Now x plus 8 times x plus 7. So x into x plus 7 plus 8 by x plus 7. X squared plus 7x plus 8x, 56. So I have x squared plus 8x, that is 15x plus 56. So this is what I've got, x squared plus 15x plus 56. So my LHS is equal to RHS, right? Okay. I hope you're getting this. Let's take one more, maybe a slightly different one. We have 16 plus 8x plus 6 to the power, say x to the power 6, negative 8x to the power 3, then I have negative 2x to the power 4 plus x squared, and it has to be divided by it is divided by x plus 4 negative x to the power 3, right? The first thing that we need to do here is that, as you can observe, this is not in any order, right? This is both the divisor and the dividend. They are not in any order, the standard form. So let's put that in the order, in ascending order or descending order, right? Based on the power. So here I have a x to the power 6. So that will be my, I'm going to take a descending order. So this will be my first term. And then I have x to the power 4. So this will be my, second term. And then I have x to the power 3. So this will be my third term. Remember, I don't have x to the power 5. Or the x to the power 5th term. I don't have it, right? And then I have x to the power 2. So this becomes my fourth term. And then x to the power 1. So this is my fifth term. And then this is my sixth term, the constant. And this becomes my first term over here. This becomes my second term. This becomes my third term. So I'm going to rearrange that. First, I'm going to rearrange. So I'm going to rewrite x to the power 6 here. Then negative 2x to the power 4, and then I have negative 8x to the power 3, and then I have plus x to the power 2, and then I have plus 8x plus 16. So you can see it is in descending order, right? 6, 4, 3, 2, 1, 0, right? And then I'm going to rearrange this one as well by divided by negative x to the power 3 plus x plus 4. So now we are good to go. So let's divide this. Okay, so I'm just going to copy this. Right. Maybe I'll just go here. And it has to be divided by negative x cubed Okay, this is what I've got. So I have a negative 6. So that is 6 times 6, x times x times x times x times x times x. 1, 2, 3, 4, 5, 6 divided by negative, that is x times x times x. So these three x's cancels out, right? So I'm left with, right, x to the power 3, correct? Yeah. That will be a negative x to the power 3. Yeah. Okay. So let's do this quickly. So I see that the time is already 6:30. Okay, we'll try to do this quickly. So I have negative x to the power 3 is my quotient. I'm going to multiply that. I'm going to multiply. So I have negative x to the power 3 times negative x to the power 3 plus x plus 4, right? So negative x to the power 3 will be positive x to the power 6, negative x to the power 4 plus that is negative. The negative 4 x to the power 3. This is what I get. So let me do this quickly. Negative x to the power 4. Then I have negative 4x to the power 3. So this is subtraction. I have negative, then this becomes positive, this becomes positive, right? Let me erase this. So negative, the x to the power 6, negative x to the power 6 cancels out. So this is 1, so it will be x to the power, negative x to the power 4, right? And then I have negative 8x to the power 3. Negative 4, sorry. Negative 4. So negative 8 plus 4 is negative 4x to the power 3. And then I bring down x squared. Okay, so x squared, negative x squared, negative x to the power 4 by negative x to the power 3. So this will give me, it has to be a positive x, correct? So this is going to be my second term in the quotient. So now I'm going to multiply negative x to the power 3 plus x plus 4. So now I have negative x to the power 4 plus x squared plus 4x. So this is what I get. Negative x to the power 4 plus x squared, right? I have an x squared here. I don't have anything for this one. And then I have a 4x plus 4x. So this becomes positive, this becomes negative, this becomes negative, correct? And these two cancels out, and these two cancels out as well. And I have what I'm left with is negative 4x to the power 3. So I just bring this down. And then I have negative 4x. Correct? Now I bring down this I could have brought it down here itself. I can bring down 8x here. Right? So I have negative positive 4x. And then I have 16. So I have a negative 4x cubed, which has to be divided by negative x cubed. So I get negative 4. This is positive 4. This is going to be positive 4 over here. Right? So I have positive 4. So I have a negative 4x cubed and plus 4x and then plus 16. And I have to subtract this. So this becomes plus, this becomes minus, this becomes minus. So all of them will get cancels out. So this will be my, this is my quotient, negative x cubed plus x plus 4. We'll do one thing. We will go through this again in tomorrow's class. Okay? Take care. Bye.